Alright, so today we are going to talk about the mole. Alright, when you hear that word, there's probably other things than what I want to teach you about that you think of. You might think of, the skin marking. You might think of the underground dwelling animal, the mole. If you pronounce it a little bit differently, it looks like mole. But what I really want to discuss with you today is the chemistry application. A mole is a counting unit that is used in chemistry. So let me explain what that means. So, in chemistry, we deal with tiny, tiny things you can't see with the naked eye, and you can't see with a typical microscope, all right? So dealing with individual atoms, individual molecules, really just isn't feasible, because you can't see them, you can't touch them, so we have to deal with packages of these things, okay? So the mole is kind of like thinking like a dozen. When you say the word dozen, you know you're talking about 12 of that thing. When we say we're working with a mole of something, there's a specific number that we're working with, okay? So let's talk about what that number is. The mole is 6.02, you guys aren't going to have to use the second 2, 6.02 times 10 to the 23rd particles, okay? What that number means is it's a 6 followed by a 0, a 2, and then 21 more zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So it's that number, all right? We don't ever want to write that number out. We always want to use scientific notation. So if you need a refresh on scientific notation, there was a video on that from first quarter under the first unit of our stuff, all right? Just another reference for this number, 6.02 times 10 to the 23rd, is called Avogadro's number. It was named after Amadeus Avogadro, who was a famous chemist at the time that this number was discovered. Then one last thing to utilize with the mole. So the mole is a unit. It's, like if you were to abbreviate a dozen, it would be DZ, all right? Mole is abbreviated MOL, all right? Reason for that, what does M stand for? Meter. What does ML stand for? Milliliter. So this is really the only option we have to make it different from the other units we've already seen, all right? Just to give you an idea of how big this number is, all right? This number, nowhere near the number of people on Earth, all right? There is 7 billion-ish people on the Earth. That would be 7 times 10 to the 9th. Okay, so 7 with 9 zeros following it. All right, a mole of pennies on the Earth. All right, there's maybe, for each person on the Earth, maybe 100 pennies, which would make it 7 times 10 to the 11th. Okay, mole of stars in the Milky Way, we're getting to a big number here. We're probably talking like 10 to the 15th, 10 to the 16th, but still, that's still a billion times smaller than the mole. All right, the only thing that is life-size that we can see, feel, and touch that even relates to Avogadro's number is considering all of the stars in the entire universe. Okay, so I'm just trying to emphasize the fact that this is a huge number. All right. Now, we use this gigantic number because it puts molecules and atoms into things that we can actually count and see. All right, there's 210 moles approximately in a gallon of water. All right. So not only does this emphasize how big Avogadro's number is, but it should also emphasize how tiny atoms and molecules are. Okay, because you need to put a lot of them together to get to the point where you're actually seeing something. So, using the word the mole, or the unit the mole, you have a mole of something, you have 6.02 times 10 to the 23rd of whatever that something you're talking about. Okay, it's like when you say you have a dozen eggs, you know you have 12 eggs. If I say I have a mole of eggs, then that's communicating to someone else that you have 6.02 times 10 to the 23rd eggs. Okay? Eggs, however, not a good thing to count with moles. Alright? You'd never be able to use a mole of eggs. I don't think you can't even accumulate a mole of eggs at the same time before they all go bad. Alright? So dozen is a much better counting unit for eggs, whereas the mole is a much better counting unit for atoms, okay, or molecules. Because a mole of copper atoms, 6.02 times 10 to the 23rd atoms, that's actually something, it's not big, but you can hold it in your hand. You can see it. Alright, so it's going to be, something about, that fits nicely in your palm. So using moles for atoms and molecules comes in very handy. So, some questions that you might see related to the mole and Avogadro's number. So, for problems like this, how many particles in 2.5 moles of iron, dimensional analysis is going to come in handy again. So, just to refresh you on dimensional analysis, you take the number that you're starting from. We know we have 2.5 moles. You write that out. Alright, I'm using the mole abbreviation. And then you're going to set up an equivalency, two things that are equal to each other. Now, we always put the part we're trying to get rid of, the mole, on the bottom. Alright? So, do we know a number that 1 mole is equal to that would get us 2 particles? Alright? So, what I'm trying to get you to use is Avogadro's number. Alright? 6.02 times 10 to the 23rd particles, atoms, whatever the problem is talking about. Alright? You know you did your dimensional analysis correctly if, like in math class, when you're multiplying x times 1 over x, that these x's cancel out. Okay? You know you're doing your dimensional analysis right if you are canceling out moles and leaving it with the unit that the question's asking you for. Okay? So when you're calculating this, your calculator, you're going to type in 2.5 times 6.02, and your calculator should have some sort of button to replace the times 10. Alright? On some calculators, usually it's an E. Some calculators, it's 2 E's. They're capitalized. Alright? So it might be E23 or 2.5 times 6.02 EE23, depends on your calculator. Alright? If you are on a phone, if you turn the phone sideways, usually this number will come up. Or this button will come up. Right? So when you type that into the calculator, you're going to get an answer that looks like depending on your calculator, it may write in times 10 for you, which is helpful, but if your calculator spits out something like this, 1.505 E24. What that E equals, E means times 10. And then your number that follows goes superscriptive of the 10. Alright? So the answer here is 1.5 times 10 to the 24th. Alright? You should never write E as your answer on a test or a quiz or a worksheet. Alright? Now, one more thing I want to go over is why I wrote 1.5 and not 1.505. If you guys remember, it's sig figs from the beginning of the year, and if you need a refresh on that, there's a video on that too. Okay? Sig figs, when you're doing multiplication and division and things like that, is determined by the least amount of significant digits. Alright? So, again, conversions, we're going to stick to the same rule. They don't affect your sig figs. What affects your sig figs is what you're starting with. So we started with 2.5. That's 2 sig figs, so we have to end with 1.5 because that's also 2 sig figs. All right, so we'll do some more practice. So this time, how many particles in 5.0 moles of oxygen? I did this one on purpose because you have to remember oxygen always forms an O2. Okay, so if we have 5 moles of oxygen, that's really like having 10 moles of single O's. Right? And since we're wanting to get into the particles or the atoms, and we have to account for that. So our starting number is going to be 10 moles. And actually, I'm just going to use the abbreviation. And then you set up your dimensional analysis. Sorry. Where do I put moles? Okay, goes down at the bottom, and then we put Avogadro's number at top. Alright, so when you type this in the calculator, you're going to have 10 times 6.02. Find your E button, and then type in 23. The E button oftentimes isn't actually on the button. You have to hit like second or shift, or there's a key you have to get because it's written on the, like above the button. Okay? And that spits out to you 6.02 E24. Alright, which we are going to account for our sig figs. We do have 2 sig figs, so we actually have to say 6.0 times 10 to the 24th particles. Okay? Next one. You can also go the other way. Alright, so in this case, and let's just use the word atom instead of particles. Avogadro's number can be attached to anything. You can have 6.02 times 10 to the 23rd of any like physical unit. Right? It can be particles, it can be atoms, it can be molecules. Okay? So we have 3.27 times 10 to the 40th particles, or, sorry, I'm going with atoms. Alright, which means this time, what number's got to go on the bottom? Because it's 1 mole equals 6.02 times 10 to the 23rd atoms. Alright, so 3.27, you're going to have to use your E button twice. So we have 3.27 times 10 to the 40th. And then because that's on top and the 6.02 times 10 to the 23rd is on the bottom, we're going to divide this time. 6.02 23rd. And then your calculator spits out this. 5.4318. And a whole bunch of more decimals. 10 to the 16th. Alright, we started out this time with 3 sig figs, so we can keep 3. So our answer is going to be 5.43 times 10 to the 16th. Our units this time is mole. Okay, so make sure you have notes in class and do the online quiz.